Energy Transition Now with David Linden.
Hello, everyone. I'm your host, David Linden, the Head of Energy Transition for the Westwood Global Energy Group, and you're listening to Energy Transition Now, where we discuss what the transition really means for the oil and gas and the broader energy industry. In our last episode, we spoke about the importance of technology and innovation in decarbonising our economies. One of the technologies that could play a vital, if not essential, role in making net zero emissions by mid-century possible is carbon capture, utilisation and storage, CCUS. To talk to us about the potential for CCUS, I have the real pleasure of having Kentaro Hosomi, Mitsubishi Heavy Industries MHI Group, as my guest today. Ken brings over 40 years of experience to the MHI Group with a focus on the power and energy sector. He is currently an Executive Vice President at MHI and serves as the Chief Regional Officer, a CRO, for the EMEA region, and is also the CEO of Mitsubishi Heavy Industries EMEA. In these roles, he leads MHI's efforts to grow its business across the region and across MHI Group companies. He previously served as the President and CEO of the company's Energy Systems domain, and was deeply involved in MHI Group's energy transition strategy. He is also a member of the board for Vestas Wind Systems, where MHI holds a stake. Ken, it's great to have you on the podcast today. I very much look forward to our discussion.
Thank you very much for your introduction.
Absolute pleasure. Now, let's get into the questions and what we're really here for, I guess. MHI is a very significant industrial group. You've got global operations, 80,000 employees, 4 trillion yen of revenue, etc. But can you maybe just talk to us a little bit around how MHI is helping to decarbonize its customers or more broadly, even the global economy?
Thank you very much. I'd like to say first that the MHI, through its history, has a very broad portfolio of technology solutions. Carbon capture is one of the technologies we are leading the world with, but also together we have invested quite a few amount in developing hydrogen as an alternative fuel for that. And also we are already implementing measures like waste heat recoveries, those would help the industry to decarbonize. And those through those technologies, we are sort of focusing ourselves in this energy transition, mainly on the decarbonization of the industries, which are really hard to abate such kind of carbon emissions. So through these technologies, I think we can contribute to reach the net zero or carbon neutral world.
Thank you. Yes. Now, I had a look through your medium-term strategy, and I could see that things like hydrogen do play a very big role, and maybe we'll have to come get you back on again to talk about hydrogen another time. But we're here to talk about CCS. So, a key question I would have for you, of all the different technologies that are out there, why have a focus on CCS? What's driving that for MHI?
Looking at the world, as I said, there are many industries which currently still we need those products in order for the world to develop, such as steel or cement, aluminum, fertilizers, these kind of industries. These are essential for our daily lives and for the development of the world in its entirety. So these industries, as of today, heavily rely on fossil fuel for the production process of those kind of products. And as of today, looking at available technologies, of course, in the future, as I said, replacing such kind of fossil fuel with hydrogen, these kinds of things, this could come into the picture. But as of today, what we need to do is to eliminate the carbon emissions from those kind of processes. And there, I think the carbon capture technology is going to play a very significant role in those kind of industries.
Just so I maybe understand, are you saying that it's a choice between hydrogen and CCS, or are you saying CCS is something that can be done now and maybe hydrogen later?
Yeah. CCS is a technology we can apply now. And of course, this CCS also works in the production, in the process of producing hydrogen as well, as you know. Cracking the fossil fuel and separating the CO2 will make hydrogen. So this sort of technology will not only serve as the carbon capture from the existing industries today, but also it will work in the future in the process of producing hydrogen as well.
Very interesting. Okay, so it's kind of an enabler for the hydrogen economy as well. Very interesting. Right. Okay, so we started to get into a little bit around how CCS works and those things. And actually, there's a few good videos on your website as well, actually, that you have that sort of works you through the process. But can you maybe just talk us through a little bit about what solutions are available or need to be developed?
Basically, our carbon capture technology is based on a sort of a solvent, liquid, and absorbs the CO2, the carbon dioxide, from the exhaust gas of such kind of process. This is basically our technology. And for that, any industry which is burning the fossil fuel and emitting the exhaust gas, this can be applied. So as I said, the hard-to-abate industries like steel or cement, these kind of industries can benefit from that. Of course, first it was used on thermal power stations. This is the start of our technology, but also now the application is spreading to those like the shipping, where we are developing a more modularized technology for capturing carbon from the shipping emissions. So there are various applications based on our technology. As of today, it's readily available as of today.
Okay, and just for clarity, then, for folks who maybe haven't come across CCS before, you talked about MHA having a solvent liquid kind of a solution. Is that the approach that everybody else takes as well, or is what you're doing unique?
There are various approaches to carbon capture and utilization technologies, but this is this solvent technology we have already been doing for more than 30 years, and we have already many projects in the world which have applied such kind of projects. The largest being to a coal-fired plant in the United States, which is as of today the largest single carbon capture plant in the world.
And that uses MHI technology.
Yeah, that's right. Yeah.
Very interesting. In terms of so we've talked about, or certainly I talk to a number of clients about CCS and its readiness and its applicability, and certainly, some of them are baffled, should I say, that why hasn't CCS already been deployed so much? There's clearly it's a driver here, which is about decarbonisation. I'm happy to hear if there's more to consider here than just that. But there must be some barriers to its deployment as well, whether it be technical or commercial. I mean, could you maybe just sort of allude to some of those and help us understand why we haven't all got CCS on all our industries right now?
One of the challenges of the carbon capture is that eventually the captured carbon dioxide has to be stored or utilized. And of course, we also working on the R&D activities for utilization of captured carbon dioxide. At this moment, the most, I would say, viable solution would be to store the captured carbon captured. So in terms of that, I think it was a little bit difficult in finding proper storage areas. That was one of the challenges we had. But looking at, for example, in the UK right now, the UK government is promoting the storage into the depleted oil and gas fields in the North Sea. As you already know, there's the UK government is encouraging the industries to form clusters, and basically those emissions will be captured and transported and stored in the North Sea. That is the whole plan. And such sort of initiatives is breaking through is one way to break through those kind of challenges. One other thing, the challenge is that of course, CO2 itself, unless we find a way to utilize that, it doesn't have any commercial value in that sense. So it means that this facility of capturing CO2, it is a sort of some kind of an addition to the production facilities for that. So that kind of I would say capital investment. This has been a challenge, but also in that sense, the UK government is introducing some, I believe, is some measures to facilitate such kind of carbon capture and storage scheme. So we're expecting that this kind of scheme would help ease, the investment into such kind of carbon capture facilities, and this will also help this carbon capture to be more, I would say, applicable to many industries.
Very interesting. Thank you. Yeah, I mean, there were some interesting things in there that you talked about a little bit earlier as well around maybe some of the technical constraints. So you talked about modularization to make this work elsewhere. Just so I understand, so the technology is kind of ready, but you maybe need to do things like modularization to reduce cost and actually make it technically feasible, if that's fair, in different industries. Am I interpreting that correctly?
Yeah, of course. We also, on our side, as the producers of such kind of carbon capture systems, we are trying to drive the cost down. And one way we are heading is that we are improving our solvents so that making it more effective, meaning that we can make the facilities smaller than the previous cases to capture the CO2 with more efficient solvent. This is one way, and we are already testing such kind of new solvents in places like Mongstad, Norway, where we are getting very good results of those kind of efficiency. This is one way. And also the other thing is that there are many smaller industries and applications which needs carbon capture. Like, for example, waste to energy plants. These are much more smaller, facilities which also need such kind of carbon capture technologies. And for those small, we are developing modular sort of solutions for such kind of smaller applications, so that in order to capture CO2 from such kind of smaller installation, we can also, multiply such kind of modular modular solutions in order to solve such kind of issues of such smaller emitters.
Very interesting. Very interesting indeed. A question that often gets asked, Ken, is that, and maybe this is the criticism that's leveled, because you're at the intersection of the CCS and the hydrogen economy, as I can see. There is a question that is often asked around whether sufficient carbon is captured when, for example, producing blue hydrogen. And, old studies have shown that it's less than 90% and so forth. And there's been a lot of, I don't know if you follow your LinkedIn feed or anything like that, but there's a lot of chatter on LinkedIn and other places that it isn't good enough, the carbon capture technology for blue hydrogen in that sense. What would you say in response to that? Because you're clearly working on the latest technology associated with that.
With our technology, we are always going for more than 90% of carbon capture from the flue gas from such kind of emitters. So I think, yes, looking at the technology as of today, we think that this contributes significantly to reducing the carbon emissions from the existing industries. Of course, there will need to be there is room for further innovation in the future. And we will not stop here. We will always try to improve our technology and make it progress through various projects. But in order to do so, we need to work with many partners, I would say, especially the emitters or those who are responsible for transport and storage of such kind of carbon. Captured carbon. We cannot. We have to turn this whole, I would say, the carbon circulation or carbon cycle into a more effective and more economical, so everybody can use such kind of things. So This is where we see a very strong need for partnering with our various stakeholders in this circulation. So in order to move this technology forward to be more efficient, I think that is the status of today.
Perfect, Ken. I appreciate that. Thank you. Yeah. And people often forget that things get better rather than worse. So yeah, that's technology in progress. But that's good to hear that you're working on that. And maybe that's a good way to sort of come to the question I wanted to ask you around sort of, I guess, call it building a business case. But there are a number of things you've talked about here, whether it's about smaller industries or clusters, and the concept of the lack of commercial value and how you're working through that and what governments need to do. What is it actually, in simple terms, maybe, what is it that is needed to make a CCS project actually work?
I think one of the most significant part is a government policy or support in such kind of building the whole value chain of carbon capture and usage and storage. So it means that I think in order for the industry to move one step forward, I think some kind of incentives is required, not only on the capex side, but also this carbon capture facility is, in order to recover such kind of investment for the carbon capture facility, it needs some kind of predictability that this carbon capture business will run for a certain period of time. In order to ensure such kind of a certain business for the carbon capture, there's some kind of predictability in the business. This, I think, the government has, I would say governments will have to play a significant role in creating such kind of predictability.
No, I can see that, and that's often something projects I've worked on myself. It's a similar sort of question. Is it looks fine, but you need the government incentive to either create the commercial value, and how do you do that? And there are many different models for achieving that, and I guess the UK's got one approach to that. If you're thinking about a project, though, what are some of the other challenges that you can come through in a business case? I don't mean it's a challenge in itself, but what is it you need to prove in a business case? So I'm thinking things like, you talked about a cluster. Why is clustering good? Is that because that's where you get a high concentration and a longer term supply, should we call it, of CCS? And that's reason why people are choosing clusters, or is there other reasons that can go, to justify why you would do CCS in that particular place?
I think the clusters means that the flue gas from each emitter is different. So we need a sort of different solutions for each of these emitters. So that's why I mentioned about the modular approach. This could be a better solution for such kind of different emitters. And the one thing that I'm referring to a cluster, or the UK government is going for cluster, is that this, as I mentioned earlier, the challenge was transportation storage in a very, efficient and physically, acceptable way. This was one of the challenges of this carbon capture being commercialized. So in that sense, the transportation to make this transportation and storage in an economical and affordable way, it is good that this kind of emissions will be gathered as a clusters and will be treated in a single source. This is a sort of the idea behind clusters being more effective economically.
Okay, that's very clear. No, that makes a lot of sense. So in a cluster, you got different, as you say, modular solutions for the different emitters, and then you're trying to be as close to reduce the transportation and the storage costs to make that, as you say, economic.
Yeah, exactly.
Sense.
Yeah.
Makes a lot of sense. Okay, very interesting indeed. Okay, so MHI in itself is clearly, as you talked about, you had one of the first, or the biggest, should I say, carbon capture storage plants on thermal power out in the US. And you've mentioned a few other examples of where you have succeeded. Could you maybe talk us through a few other examples of where this technology is proved particularly interesting or successful?
I think what we are developing with other partners right now is also the way, not only storage, but utilization of the captured CO2. I think we eventually need such kind of solutions. Because physically, the storage places could come to some kind of limit in the very long future. But if we can use the captured CO2, this is also one way of solving the issues. So in that sense, we are making such kind of joint development efforts with other companies for the utilization of the captured CO2 for things like changing into a sort of an alternative fuel, synthesizing with other, elements, and producing synthesized fuels like methanol. This is one of the things which we are trying to develop. And there are various, solutions which we are also looking into to utilize such kind of captured CO2. Yes, there is the technology improvement will take us, I think, to a new dimension for such kind of CO2 technology, CO2 value chain.
Yes, ideally we end up trying to use some of the carbon as well in various industries, and we certainly see quite a few new industries popping up. You can now buy, whether it's building materials or others that ultimately take carbon from the air and or directly from an industrial plant and use that to make other materials. Okay, wonderful. Where do you see the future of CCS growing and your future sort of focus? You've talked about all the different industries, but where is the biggest sort of need and the future focus needing to be?
Yes, looking at the world, and the world as a whole is heading for carbon neutral in the 2050s. This is the sort of I would say the consensus of the global consensus for our target. One thing is, I think one way in achieving that kind of carbon neutral world is through the use of renewable energies and electrification through renewable energies. This is obviously a very effective way in the way towards carbon neutral. However, looking globally, there are not all the areas geographically are blessed with such kind of conditions to make the renewable energy competitive. There are places where the wind is not so strong, where the sunshine is limited. These are looking globally. There are places like that, and also those are the areas which are relatively heavily populated, and they need further growth in the economies like the Asian countries or African countries, these places. And so in order to grow economically, but at the same time not emitting carbon dioxide like the Western world has been doing for years, I say. For those kind of areas, I think this carbon capture technology is indispensable for the economic growth and prosperity of such kind of countries. So yes, the movement will start from Europe or UK and these countries, but I think globally we need such kind of technology to be spread over the world in order to realize, the economic prosperity and decarbonization at the same time.
Absolutely, no, thank you. Certainly, I think any credible climate scenario recognizes that the capture and removal of CO2 from the atmosphere is absolutely fundamental to making net zero as such possible. Wonderful. Okay, Ken, thank you. We have run out of time, as is always the problem with these things. But, it's been really great to have your views on the future role of CCUS and including, I guess, that all important business case. How is it going to work going forward? So, thanks for sharing, I guess.
Thank you very much.
Insights.
Thank you very much, David. Yeah, thank you very much, David.
I much appreciate it, Ken. And thanks everyone for listening as well. Hope you enjoyed it. Please make sure you subscribe, give us a great rating, and share with your friends, and talk to you next time.